In this video, we're going to find the exact value of all 6 trigonometric functions evaluated at angle theta if the sine of theta is 3/7, so I guess we only really have to find 5 of them, and cosine theta is known to be less than 0. This is going to make us put together a lot of things we know about the trigonometric functions, along with reference angles. So the first thing I want to do is identify what quadrant theta is in, right? Because that's going to help me figure out what sign all of the other trig functions have. And when I look at this, cosine is negative, but sine is positive. Well, sine's only positive in 2 quadrants, quadrants 1 and 2. Everything's positive over here, so cosine I know to be negative in this quadrant. So I'm dealing with a second quadrant angle. All right, well, what else do I know? Well, I can think about this as a y-coordinate and this is an r-coordinate. Well, not a coordinate, but an r value, right? The distance away from the origin. So it's like, I don't know, I have something that's 7 units long, and that would have a y-coordinate of 3. All right, well, what I'm starting to imagine is that maybe I see a right triangle, right? And I can flip that triangle around and kind of draw it over here just to make it a little more clear. That take this and flip it over, that would be a 7 and a 3, my nice happy right angle. And this angle that's in my right triangle, that's not the angle I care about, theta, but it is my angle, theta bar, that reference angle. So I can do right triangle trig to find the value of all 6 trigonometric functions evaluated at theta bar. Well, I know that the trig functions I actually care about evaluated at theta can only be different than that by a sign, a plus or a minus. So all we need to do is find this missing side, write down a whole bunch of right triangle trig stuff, and then put pluses and minuses where they go for an angle that we know is in the second quadrant. All right, so I'm going to call this missing side A, and it would be 7 squared is equal to A squared plus 3 squared. So 49 is equal to A squared plus 9. 40 is equal to A squared, and I need to take a square root of both sides, and I might very briefly write the square root of 40. But I know that's 2 times the square root of 10, and I apologize, I've written off the bottom of the board there, but A is 2 root 10. All right, so now we can evaluate our trig functions at the angle I actually care about. Sine is the opposite over the hypotenuse 3/7. Well, I hope I got that one right. It was given to me. And it's reciprocal 7/3. All right, well, now let's think our way through it. I'm in the second quadrant. Sine and cosecant are positive, and all of my other trig functions are going to be negative. So I already can affix the correct plus or minus out front. These 4 are going to be minus. Cosine in my right triangle here would be the adjacent over the hypotenuse, 2 root 10 over 7, and with that minus out front because the angle I actually care about is in quadrant number 2. Tangent, the opposite over the adjacent. And cotangent, it's reciprocal. And secant is the reciprocal of cosine. And there I have it. I've evaluated all 6 trig functions at this angle theta by thinking about a right triangle that actually has the reference angle in it. That's it for now.